Howdy and welcome back. So we're going to, in this video, introduce move semantics. We'll first begin, though, considering some of the special member functions that the C++ compiler will generate for your user-defined types. So C++ 1998, so the 1998 standard version, if you will, of the language, had four such functions: a default constructor, the destructor, copy constructor, and copy assignment operator. Recall that we said the default implementation of the copy constructor and copy assignment operator was a member-wise copy, and that the destructor was more or less a trivial kind of do-nothing definition that was provided for us. Likewise, the default constructor didn't do anything interesting either, which is why we've come to define it for pretty much any user-defined type that we were created for which we would like default construction to take place. Remember that if we were defining say a destructor, a lot of times we were doing so because there was some sort of resource that we needed to go ahead and release, such as maybe dynamic memory, provided that the class owns some sort of dynamically allocated object. And in those cases, remember that we often needed to also provide some sort of definition for what it means to perform an initialization of one object with an object of the same type, or to assign an object of that type to one that's already existing within our applications. Recall that in these cases where the object owned some sort of resource, the default mechanism, a shallow copy or a member-wise definition for the copy policy of that type might be insufficient. So in the case of our linked list, our kind of pseudo vector implementation, and even for our trees or graphs, what we would have wanted to have done was implement a deep copy policy. And to do so, we'd go ahead and provide definitions for the copy constructor as well as the copy assignment operator. So again, just to kind of recap from maybe long ago, the functions shown in blue here, the destructor, copy constructor, and copy assignment operator, kind of comprise this idea of a rule of three, and that if you declare any one of them, you should define all of them. Okay, so why are we talking about the past? What's the future to bring? Well, C++ 2011, the 2011 standard or version, if you will, introduced two additional special member functions. So the special member function club has two more inductees, the move constructor and the move assignment operator. And these are kind of doing, I think at this point, what their name might suggest. There's going to be some sort of moving of, say, a resource owned by one object to another object. So a change of ownership of a resource. And we'll see this is pretty cool. We'll be able to kind of explicitly invoke these sorts of moves of resources from one object to another. But what kind of the semantics of that, of what it means to say to perform that move, are going to be defined in these very special functions here, the move constructor and the move assignment operator. So to go ahead and get into this a bit more, what we're going to notice is that the declarations for these two special member functions is going to look very similar to our copy constructor as well as our copy assignment operator. The difference is going to be is that the arguments are not going to be passed by const reference to the move constructor and the move assignment operator, but instead are going to be passed as Rvalue references, as denoted by this double ampersand modifier on the base type. Then we see that in the move constructor as well as the move assignment operator. And we'll kind of get into what that means here momentarily. What's an Rvalue reference? How's that different than a vanilla reference or a L-value reference, if you will? And we'll even briefly touch base on kind of what a universal reference is here, which can be either a R-value reference or an L-value reference. And at this point, I don't expect you to know this terminology. So what's an L-value? What's an R-value? That will come in this lesson. But just understand this is what the signature and return type looks like for our move constructor and our move assignment operator. And because we will be performing a shifting of resources from the object residing on the right-hand side of the equal sign to that on the left-hand side, we cannot possibly pass these objects by reference because we're stealing the object on the right-hand side's resource and therefore modifying it. I'll go ahead and provide an example to hopefully reinforce this notion and what this means. But let's kind of continue going through. So as you can see here, with this addition, our rule of 3 is effectively going to become a rule of 5. And from this point forward, the expectation would be that you're not only defining, where applicable, a destructor, copy assignment operator, and copy constructor, but to that 3, you're also going to provide a definition of a move constructor and a move assignment operator from this point forward. So if you declare a destructor, copy assignment operator, move constructor, or move assignment operator, you should really define all of them. And this is going to become known from this point forward as the rule of 5. So move semantics. So these are special member functions that make it possible for compilers to replace expensive copy operations with less expensive moves. And well, what does it mean to go ahead and initiate this transfer of resources of some object to another, to move them from some object to another object? Well, that's going to be defined in our move constructor as well as our move assignment operator. So it's going to allow us to define what move means for an object of one of our user-defined types. So what we'll see here is, okay, yeah, the compiler can go ahead and leverage this as it's compiling our source code into a runnable execution, but we can also leverage it as we're writing our code by performing move operations explicitly, which I like to think of and which will be helpful to think of when we begin introducing smart pointers, particularly the unique pointer, is that think about moves in terms of ownership transfers of some resource owned by one object to another. And if you keep it kind of at that level, what's to come within this lesson will hopefully be relatively clear. So with that in mind, let's go ahead and talk about this Rvalue reference a little bit. And note that for our discussions here, we're talking about an Rvalue reference and not a universal reference, which has these, it looks the same in some contexts, but well, you don't need to worry about that right now. We're just going to introduce this Rvalue reference before we begin kind of considering this concept of object ownership of some sort of resource. So with that ado, I'll meet you in the next video.